Thank you. Hello, everybody. Thanks for attending. My name is Christian. I'm one of the founders of Crate. And my background is actually industrial engineer, but immediately after university, I went into software. And since 8 years, we're working on Crate.io and CrateDB. And today I will show you some basics on AI, so like how you really get there and some recommendations there. Then I will show you a very specific example in manufacturing, how you can use Edge and AI in the cloud and with a particular outcome. And then very briefly talk about the enabling technology underlying this. So when we talk about this topic and this whole reason why you're here is that you are among those who understood that this is the big groundbreaking thing that is happening currently with AI. You can easily compare this with the invention of the printing press. This is kind of the magnitude that we're facing. And the key to all these things, machine learning, AI in general, and smart manufacturing as a result from it, this has a lot to do with data strategy and obviously underlying technology there. So we're in what's called the AI first century. And actually, this started more than 50 years ago already. So this is when the term AI was coined and invented. And then 50 years, almost nothing happened, but a lot of groundbreaking things were developed, but they didn't just get into like every people's hands. And where we're now in is essentially the benefit for manufacturers and corporations and just any company, big or small, that we have this super cool intersection of it's very easy to collect data. You have access to cloud systems that are fairly cheaply available now. And there's a lot of tools and a lot of expertise already here. And this is essentially easy to do it. And there's a very low entry barrier to do it. And the best part is it's certainly not too late. So if you're not into this, now is the time really to establish that. So there is this mathematician, Charles Babbage, who essentially is called the father of the computer. He wrote, without having computers, the concept of a modern computer. And he said an interesting thing, which is a quote of him, man as a tool-making animal. So this is really how we separate from animals, right? And there are 3 waves of tools that we have built since we exist. So the first one, obviously, were tools that gave us physical leverage. It started maybe with an axe, but all this industrialization and the machines, this gave us physical leverage. The second wave that gave us intellectual leverage started with the printing press and went into the computers and whatever you do with computers today. And this gave us essentially access to a lot of information, process it, and it's kind of only limited today about the knowledge what you can acquire from the future, which is not possible. This is really the third wave now, and with AI, we're entering a phase where your decision-making progress is influenced by data and the processing of data, and you get almost unlimited compute power to support your decision-making. This is huge, and it's not yet deployed in a big scale. It's really starting, depending a bit on the industries. I just want to highlight the main difference between like computer network, which is essentially a couple of nodes and systems that exchange information, which is essentially only bits and bytes. It's stupid data. The machine just transports it. It has no idea what it actually transports. The intelligence lies in the person who reads it and interprets it and does something with it. And the big thing with DLEs is that in a data network, not just a normal exchange of data network, between the nodes, you have compute functions. And this is called the data learning effect. This means that data pools that are connected and have functions applied, they learn from the data that they receive, they do something with it and give an more advanced version of what they received to the next node. This is the core principle. And so that means first you capture a lot of data, a critical mass of data, not all the data, but the relevant data. And then you have to develop capabilities where you change basically these pure bits and bytes into a valuable information. And by using AI and computers to do that, you suddenly get scale that was unimaginable before. Not just with the size of data that you can do, but the number of things you can do at the same time in parallel. And this turns things around. Suddenly, very small companies can do very clever things. So one of our investors has a portfolio company in Cambridge in the UK, and they are essentially a very small company, maybe 40 people. They're doing now a daily revenue between 10 and 50 million per day. And how they're doing it, they're arbitrating power consumption in networks. And they do it with AI, and they're like 10x better and faster than the big REVs and all the big energy players. They are using AI since 5 years. So this is just an anecdotal example of what is meant. So the fundamental key, obviously, is get data. And in traditional IT departments, getting data gets pushed off very easily because this is so expensive and our traditional architectures can handle it and all of that. But that's obviously no longer true at all. So there are just many ways how you can collect data. I don't go into that in detail, but it's obviously in manufacturing a lot of sensor data, but it's also customer data, product design data, simulation data. It's manually tagging data in order to use it. And especially on the manufacturing side, you have obviously the shop floor, but you also have ERP systems, you have customer feedback, you have logistics, you have quality management control systems and stuff like that. So at this point, I'd like to recommend, if you're interested, this book. It's called The AI First Company. It's a very short book, and it's a brilliant summary of how to perfectly roll out an AI use case in an organization that is huge or an organization that is really small. I can definitely recommend that. So how do you put the data to work now? This is a standard cycle that essentially scientifically is approved now, and this circle, you probably know it, is you have a business understanding of what you want to achieve, you define the key data points that are relevant for you, you try to understand what impacts your process or your EBIT or whatever, and then you start to collect those data, you prepare the data, you enhance the data, you tag the data, you use manual tagging methods or automated tagging methods. And from that, you make a model, and then, or maybe more models, you select the model, and in the very end, you deploy the model. And these red arrows just symbolize all of this is interlocked and connected. Just like Michael from Henkel said, it's not a linear process, it's an interconnected, iterative cycle that you have to do. So that's the basics. Let's talk about a very specific use case. And this is about a welding process in a high-speed manufacturing plant. This is Bloom. They started in 1952 producing horseshoes. They came a long way. They're now a global market leader for fitting solutions. So very likely in your kitchen, in your drawer, or cupboard, you have their fittings deployed. When you can easily push out a drawer and throw it back, and it will slow down and close perfectly. That's exactly what these guys do in 11 production plants around the world. So what did they started to focus on? Well, there is a long production process, many steps, and somewhere is this welding. And the welding happens early on in the process, and if it's not good, and they don't detect it, this is very expensive, obviously, in the end. So they want to save money, essentially, and reduce cost of poor quality. How they do that? They want to learn very early in the process if this welding happened in a good way or in a bad way. And the thing was that in these production machines, obviously, there is a testing already deployed, but it just wasn't accurate enough. If they put it up a notch one notch up, it threw out a lot of good parts, and if they put it one notch down, too many bad parts got into the system. And this is how they said, let's do this per welding and learn how this is impacted. So the questions they want to answer was, how can we learn from a welding process that takes 500 milliseconds? What does really influence the quality, and how do we understand that? Can we do this at scale with very large number of weldings? And can we basically predict the quality of the product depending on this critical welding process when they put very large steel parts together? And also, can we do it in real time, of course? Can this happen during a process that only takes 500 milliseconds? And so how that worked before that was, you have this welding process, it takes 500 milliseconds, it produces 30,000 data points, which is essentially the current that is drawn from the system when the welding happens. And they produce 70,000 parts in one machine per day. That's 2 billion records per day. And they have in each plant between 5 and 10 of these machines. So it's a mega, it was mega easy to collect a lot of data from these welding processes. And they want to take a good bad decision in less than 1.2 seconds. That's the time frame they have to eject the part. So this is how it worked before. So there was a welding process, and then they had an end-of-life testing. So they put these drawers in and out for 1 million times and see if it worked or not. And then essentially they knew how reliable this is. And with AI, they essentially cut out this very long and expensive process, because they know now from all the data that they have collected, how does a welding process that is reliable in the end exactly look like, and how much can it vary around that? And so this is a very typical chain that you have in every factory. I don't go into big detail here. You have SPS systems, you have an OPC UA server. This publishes, all of that runs on Azure, into IoT Edge, through the IoT Hub, in the Event Hub, and then it gets consumed, it gets cleaned, enriched, and then it gets stored. And then, once it's available, billions of records per day, this can be processed in real time. And in the cloud, the setup was essentially actually nothing on the edge, except the IoT edge device that captures the data, and then got pushed into Azure, and then all the processing happened there. And on the other hand, when there was no cloud available, they also used it simply on the edge as part of the stack that was deployed next to the machine, where the same SPS was pushing this locally, and when the network gets available again, the data will be synced into the cloud and can be processed there. And essentially here, obviously the same process, and they could locally do in the departments with the domain experts, the analytics, the data scientists could use Jupyter notebooks, Zeppelin, R, or whatever to do their work. So this worked really well as a summary, what has been learned, and a couple of things that they understood for the next project was, it's extremely crucial to bring data scientists in the spec phase already when you even discuss it, because they will know what type of data they will need, what resolution of data from which particular sensors they will need, and basically not to have an approach where, I don't know, business defines this and then IT does the next step and then in the end comes the data scientist. Sounds kind of logical, but it's really the reality that it's not happening very often. So the data analyst is really in the center of all that you do here and is integral part in also forming the business case. And obviously the capability to collect in a cheap way, in a cost-effective way, a lot of data is a key driver for the success of such a project. So I end the talk with really just a very brief overview on the technology that was enabling this process. So essentially, CrateDB is a distributed SQL database on an open source core that was purposely developed for this type of digitalization projects. It's really a perfect building block for data analytics and AI tools. It's embedded in Azure, Amazon, or cloud, any cloud that you wish. But most importantly, it also runs completely independent of the cloud and can be deployed and self-deployed just anywhere where Java runs. So typically, when you have an analytics task ahead of you, these are kind of the key challenges. One is around the scalability. This is the compute that you need to scale, so how many processes at the same time, but obviously also the data volume that goes from hundreds of gigabytes to terabytes into tens or hundreds of terabytes at some point, and that you very often have in the setups a decentralized data silo at work. So this means you have maybe a historian or time series database that collects sensor data, but then you have an ERP system that you need to somehow correlate the data. So for example, a batch info, a product article info is matched to the proper time series event. And then you maybe have 2 or 3 systems that you need to consolidate, or they're running in separate systems. And that's kind of our approach here, that we allow to consolidate all this data in like a data hub where you mix and match ERP system, SQL database, billions of rows of time series data. And so you can very cost effectively operate such a use case. A key point here is that we have a PostgreSQL interface. That means it just connects with every tool that you have on the ingest side, but also on the analytics side, dashboards, visualizations. And so we're, as you can tell now, we're not an end-to-end solution that solves your AI use case, but we're like a Ferrari engine that you put in your Volkswagen kind of to speed up these type of tasks. I mentioned most of the key characteristics already, so high concurrent performance, but I want to point out again that the key point in this type of project is to have a system that supports various kinds of data. So you have sensor data, complex JSON documents, you have full text, you have relational data that comes from an ERP system, and essentially, usually, the cost savings are significant when you consolidate all of that and you don't run multiple systems. And obviously leverage, if you're in one of the hyperscaler clouds, all of the tools that they provide, of course. So this is kind of how a cloud edge setup works. You can have independent edge clusters that sync automatically to the cloud, or you get from the cloud a downstream data flow when you have to synchronize tables, for example. This also works really well. This is how this is embedded on Azure, for example. So you have all these, all the toolings and all the APIs to very easily connect with standard tools and APIs into the central storage, and you use a single data store to consolidate all these kind of data that can just infinitely scale. Just to give you an idea, our largest customer is McAfee, this antivirus company that stores on a 500 node cluster 20 plus billion rows a day in a petabyte system. But when they started, they only had 4 nodes and I think less than half a terabyte. So this is kind of the scale that you get. And there's no limit to that. So we're mentioned by Gartner as a cool vendor in manufacturing operations, and just now got also mentioned in the Magic Quadrant for cloud database management systems. We have focus on large manufacturing companies, but also other SaaS companies, everybody who has to do with real-time analytic workloads. Thank you very much for your attention.
Christian, thank you for your impressive inside view to virtual products, right? Software, virtual products.
Enabling real products.
Yes, right. Yeah, you're right. Fascinating. Some questions from your side?
Yes.
While I was going through the last slide, I also noticed call reporting management, CRM.
Mm-hmm.
So if a company just wants as a start to integrate their call reporting system, I mean, do you provide a solution for CRM, or you provide dashboards, or you connect, like, in a layman's language, like, the different data that you get collected in the servers, and that's how you give the dashboards for call reporting?
Yeah,
CRM?
exactly. So we would, and we do have such use case. For example, an Israeli bank is using it to consolidate the CRM data from credit fraud calls with the actual credit card transactions, and they merge it together and have a real-time access in customer service to access all this information. Mm-hmm. But we only use the data and expose the data so dashboards can be made. Yeah. We're not a CRM solution. We're basically just use the CRM data and make it available in real time. That's what we do here.
Okay, this is something what we are looking for as well.
Okay.
Perfect.
Some questions more? Then, Christian, I have a question.
Please.
If I'm looking to your track record, you have a heartbeat for software engineers, right? I think so, right? And young people worldwide. Yeah. You stay in the States, right?
Yeah.
And here in Europe. What is at the moment your impression about the situation that young people get fascinated to be a software engineer? If I'm looking around, I have 2 boys too, right? And I talk to them about that. Could you have interested, or are you interested to be a software engineer? Yeah. What is your impression out of the worldwide orientation? Software is coming up more and more to hardware in addition. Are we doing enough to fascinate young people to that?
No, I think this could be way more important to society. Mm-hmm. I think if you look to India and China pumping out, I forgot the number, but it's an enormous number of engineers, studied engineers from universities.
Okay.
And if you look to China with the giant leap that they took on AI, just to give you an idea, so the European Commission committed, I think, 25 billion over the next couple of years for AI. And in the same period, it's 200 billion in China. I think what's really cool for young people now is not only that they understand it's very easy to get into this new tech world, and you don't have to be this mathematical genius, So there's a lot of jobs in data where you don't have to be this hardcore developer that dives in a tunnel and works day and night on solving a logical problem, but especially on data science and all these analytics parts, you see a lot of really interesting offerings in universities where you can dive in. And I think we should do more, but at the same time, I think it's a fascinating area when you're young now. Yeah.
Okay, thank you so much. Okay, thank you. Christian.
Thank you.